Let's do another example here. See if we can't combine our concentration things. So, a biochemist finds a bottle that a colleague has left at his bench. That reads L-malic 8.66% mm. Okay. What is this solution's molarity? Molarity. So, a biochemist goes to his colleague's bench and he finds this bottle that says L-malic 8.66% mm. So he knows that it's a malic acid solution, 8.66% by mass. He wants to know what the molarity is. What is this solution's molarity? Okay, so in this particular case, we're going to be going from one expression of concentration to another. Okay, so malic acid. I told you that we're going to be dealing with biological molecules, so let me go ahead and draw the structure of malic acid so you see this one. Okay, let's see, shall I do it? That's fine, I'll just do it over here. Okay, so C, 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 C. We have a hydroxy there, and then we have a wedge here. Shall I put, yeah, that's fine, I'll go ahead and put the H's in. And then, of course, we have this. So this is malic acid. It has 4 carbons. It is a dicarboxylic acid. There is a carboxylic acid on one end. There's a carboxylic acid on the other end. And it's also an alpha hydroxy acid because on the alpha carbon to one of the ends, there is a hydroxy. And this wedge just means that it's actually coming out at us. Biological molecules have a handedness. Remember chirality from organic chemistry? So there is an L-malic acid and there is a D-malic acid. In this particular case, it's L-malic, so if we write it like this, it's actually coming out at us. You'll also see you'll also see it this way, the regular line structure instead of this. It's up to you how you want to draw it, whatever is most comfortable for you. I tend to draw these. I don't really care for these very much, again, because I like to see my carbons. I like to see what I'm working with. Even after all these years, I still just feel more comfortable doing it this way. But of course in the books, you're going to see it like this. So you certainly need to be able to recognize it. Boom. And OH. So that's the line structure for malic acid. Malic acid is what gives green apples their tartness. Very, very important biological molecule, as you'll find out later in the course when we discuss the citric acid cycle. Okay, so 8.66%. So 8.66% by mass means the following. So they gave us the number, 8.66%. That means this. It means the mass of the malic acid, I'll just call it malic, over the mass of solution, times 100 is equal to 8.66. So they gave us this. This is the definition. So I want to start with this. I'm going to work my way back. Okay, so now let's ask ourselves what it is that we want. Let me do this in red. We want molarity. It's really, really important that you do, that you know what it is that you want. So I want molarity. So molarity, it means I want the moles of malic acid over the total liters of solution. Liters of solution. I need those two numbers. I need this and I need this. How can I get that based on the information that I have? Okay, well, let's take a look at this. So the first thing I'm going to do is I need the moles of malic, liters of solution. The one that's quickest here, What I'm just going to do is I'm going to well, let me write out what the biochemist did. So the biochemist measures the volume of the solution. Measures the volume of the solution. In other words, he just takes it and pours it into a graduated cylinder to see what the volume is in order to get that number. Measures the volume of solution to be 17.5 mils. So in that bottle, he has 17.5 milliliters. So he has the volume, he has the denominator. Half our problem is done. Now we just need to find the moles of malic acid. Okay, so that's the second part. How do we find the moles of malic acid? Well, I need the moles of malic acid, and I know that I can get the moles of malic acid from the grams of malic acid. From the mass, from the grams of the malic acid. And my conversion factor is the molar mass. Well, molar mass is easy. I just look it up. Okay, so the biochemist measures the mass of the solution. Okay. So, the biochemist measures the mass of the solution. He puts it on a scale and he actually measures it. Or actually, he takes a glass vial, he takes its mass, he empties the contents into that vial, and then he takes that mass, he subtracts the mass of the vial that he knows the mass of, and he has the mass of the solution. So the biochemist measures the mass of the solution. Solution to be 17.75 grams. Okay, so now he has the mass of the solution. Well, we need the mass of the malic acid. Well, we just said earlier the mass of malic acid divided by the mass of the solution, the total mass, which is now 17.75 grams, times 100 equals 8.66. We have all these numbers. So now we have this equation. We just do a little bit of algebra to find the mass of malic acid. And that turns out to be actually, let me do it underneath here. Sorry about that. So after a little bit of rearranging and a little bit of algebra, the mass of malic acid happens to be 1.537 grams. Well, there you go. I have 1.537 grams. That's my mass of malic acid. I have my liters of solution, 17.5 mils. Now I just make sure that the units are appropriate. Moles of malic acid. This is my mass of malic acid. I still have to do the conversion to moles. So let's do that. So I've got 1.537 grams of malic times 1 mole. And again, I look it up if the problem doesn't give it to me. 134.09 grams. This is just basic stoichiometry. And I get 0.0115 moles of malic acid. Okay, we are done. So the molarity equals 0.0115 moles of malic acid divided by, and we said we had 17.5 milliliters, right? Okay, 17.5 mils, the unit has to be liters, so move the decimal over 3 times. We go over 0.0175 liters. And when we do that, we get 0.66 molarity, or 0.66 moles per liter, my preferred expression for that unit. So that's it. We were given a concentration in one expression, percent by mass. We wanted molarity. We wrote down the definition of molarity, and we just took a look to see what we needed. We needed moles of solute, we needed liters of solution. Well, the liters of solution is easy. You just measure the volume, so that gives you that. We use the information on percent by mass to recover the mass of the solute, the malic acid, And then from the mass, we use molar mass to get to moles. So these are the kinds of things that you want to do. Write it all down. See some sort of a solution path. There's only a handful of definitions. Molarity is moles per liter. Percent by mass is mass of the solute divided by total mass times 100. Everything should come together really, really nicely. Okay, thank you for joining us for our first lesson of biochemistry. We look forward to seeing you again. Take care.